No Lenny this time? Oh, he's here.
Right there.
Oh, there it is.
Oh, okay.
I should get like a popsicle stick or something, you know, a little pop-up, cut out of Lenny.
So you're still in the Bay Area?
Yeah.
Okay, you didn't go back or anything, huh?
No, I'm pretty happy there.
Good, good.
Weather is nice and
Yeah,
the diversity is nice.
yeah, that's true. It does have those things. At a high price, but, you know,
Yeah.
you gotta take it over that. I guess.
Pretty farce. 10 minutes, maybe supposed to start.
Where do you?
15P.
Oakland, oh, okay. Is it nicer?
Yeah, I kind of like to be closer to like restaurants and bars.
So you're in the city.
Hello.
But
Yes.
I don't have any agenda time, but I do want to ask if people still really want to push the interest to thing, or if we can just give up with that.
Like 75 minutes.
Let's do the agenda. We can get started with that then.
Yeah, something like just.
Yeah, so they are actually extending the offering with them and station appeals. So in a couple of months.
You just grab the mic or something when I'm ready.
You can
Okay,
push
Perfect.
No, only weeks. So
that's gonna be great.
yeah, so it's gonna be.
I feel like I need to start that ready to rumble. Are you ready to rumble? We leave the door open, let people wander in, but it is time to start straight up. You two gentlemen in the front, you two want to get a room? You two, you want to get a room? I don't understand. Would you shut up? We're trying to talk.
I almost had to kill somebody. Last week,
You're awesome.
Those are chicken teriyaki things.
Whoa,
which
you got-
I thought I was going to have to bail over to until I saw
Did you shine up the alley for teacher?
There you go.
He saw me like desperately running out to get a cookie. He said, no, sit back down. I'll get a cookie for you. All right, you guys are in Mboned. If you're not in the right place, sit down. Join us anyway. You may enjoy yourself. This is the note well. Note it well. Everyone nod. You seen it? Give me one nod. There we go. Agenda. Wait a minute. Okay, he flipped this around. That's okay. I had the slides in reverse order. So I guess we do start with McBride and Mirsky. I don't know who sent the deck. I had it all backwards. But I want to start with just a question about the MPrace 2 you said? The MPrace 2? Yeah.
So there was some discussion on the list.
Switch on top. It might still be off.
See the switch.
There we go.
There we go. So there was some discussion on the list earlier about the whole MTrace 2 and the port assignment conflicting with traceroute. So far, I have not seen sufficient support for giving back the port and getting another one. The failure mode only seems to happen if you're trace routing to the router that's running MTrace and you drop one packet, so you get 1 star in the trace route output. I've asked a couple of times on list, and I haven't seen any other suggestions on when this could possibly cause a problem. And also, I haven't seen very many updates. So unless there's some really compelling argument made soon, I don't see that it makes sense to deprecate the current RFC and publish a new one saying, this is exactly the same, just the port number is different. Of course, feel free to try and convince me otherwise.
Sounds reasonable. Anyone tracking that? Now, Troilus was tight on it before, but I don't see him in the room.
Stig Venas. So I'm not sure if I remember correctly, but I've thought that this would always happen if the router is like 1 hop away. So, yeah, you're right. It's the first hop. But if you're tracing a destination further away, it doesn't happen, or it doesn't happen, or it happens just always for the first. I mean, you probably get like a star for your first hop, and then it starts working for the further hops.
So traceroute starts at a port number and increments it on every hop. Actually, it increments it for every packet. It sends 3 to the first, 3 increments 1, 2, 3, 4, 5, 6. So unless you're trace routing to the device that has that, it's your first hop. That's the only time that port number would be used. For second hop, it would be, port that starting number plus 4. Third hop would be starting number plus 7. So it was only if you're trace routing to an mtrace2 capable router and it's your first hop. And what you get is one drop packet. So you'll see 1 star and then everything will work. This is the same behavior that you often see, like if ARP hasn't fully finished sorting its life out or similar. So I don't really see it causing confusion to anyone. I can draw it out on paper because it took me a while to work my way through it.
Yeah, okay, I'll think about it or maybe check on the list. But yeah, I agree though, if it's that limited, then it's maybe not a big deal.
Hitosha said, but I'm of course also of the M-trace, but is it beautiful?
No, it's suboptimal, but. So no, it's not wonderful, but to get a new port, we'd have to deprecate the current document, write a whole new document saying this document deprecates the old RFC, and here's a new RFC which does the same thing, just this is different. And it causes we could do that. I didn't see very many responses to the email thread. Like, I don't think we sent a couple being like, is this okay? Is this okay? And didn't see an update. If the working group really wants to do this and is willing to push on it, I will be happy to change my mind, but I'm not sure if that's what the working group wants. To me, the failure mode is sufficiently unusual. It's very seldom that I would trace route to my first top router. And if it doesn't work, I see 1 star and I can probably figure out what it is. So I'm not going to be like, oh my God, my router's down. I'll just be slightly confused. If I'm trace routing to my first top router, which seems like an unusual thing for people to be doing. It's on the same subnet. So if I'm trace routing to a router that's on my same subnet, that seems unlikely. Maybe I'm wording that poorly. If I'm 192.168.5.5 and I'm trace routing to 192.168.1.1, that seems like an odd thing to be doing. But if the working group wants to change it, I'm happy to take it up, but it's going to have to be something the working group does soon.
Well, personally, I think that is slightly a problem, even though you can trace the unicast trace or mtrace finally, but always in the same situation, always the first router just drop the packet or ignore the packet, and always you see a star. For me, it's strange. So, and that kind of situation can be addressed if we change the port number. Then why don't we change the port number? So the problem currently, is IANA itself doesn't want to just, sorry for saying this, but doesn't want to accept their failure. Sorry, they said it's not their failure. So that's why this is a problem. They say it's not a failure. It's a implementation problem. It's a Linux unicast traceroute implementation problem. So there is no relation with mtrace specification. There is no problem of IANA specification or IANA assignment. Only the problem is existing Linux unicast traceroute. So everyone said we don't have any problem. But honestly speaking, if the IANA accept that kind of a situation and then reassign a new port number, then everything becomes fine and it looks beautiful. So my personal opinion is that IANA, I'd like to ask them to reassign the new port number for mtrace2, and the new mtrace2 RFC will be published as with the statement that we had some conflict of the port number, then there is no specification change. And we don't say it's due to the IANA. We should not say so. This is just a problem of the existing implementation. That's why we republish the new RFC. That's all. And then finally everything looks good. Beautiful.
If the working group wants to send me a new document that says that, and the working group really wants to push for it, as I said on list, this discussion happened a while back. It kind of stopped, so I thought people didn't care. If the working group really wants to push for it, IANA has said they're happy to change it. Well, some people in IANA are happy. Joe Touch is Joe Touch is pushing back. He's not part of IANA. I'm sure we can make it happen if the working group is willing to push for it. I should point out that the only time that this shows up, it's not for the first hop router. It's only when you're trace routing to the first hop router. If you trace route through the router, you never see this, and that's the common case. It's very seldom people trace route to their first hop router because it's their first hop router. But if the working group really pushes for it, we can try and deprecate the old RFC, write a new draft. Working group last call, ISG review, blah, blah, blah. It sounds like a lot of work for a situation which to me seems very, very, very uncommon. But I'm here to serve the working group, so if that's what the working group wants, we can try it. But the working group's going to have to decide. It's not my decision.
Yeah.
And this was supposed to be short.
No, it's
Okay.
but it's a sticking point, so we have to shake it.
Okay, just one other thing though. So, so if IANA does nothing, that means that, the next time someone asks for a port number, they might give that, just like a whole range of port numbers, right? And if IANA now at this point where they start handing out port numbers to people, you will start having this problem several times in the future for other protocols. I don't know if you thought about that, but.
I made a mistake. I looked up to good, saying he's taking minutes. That was this morning. I'm glad this is being written down, and it's not. Who can take minutes for us? Well, come on, someone. Thank you. You don't have to catch up this entirely. You can sketch something, and that would be great. I think we have a recording to go through, but
continuing to like shed on.
So it's not really relevant for this working group, but I just wonder if there's more bigger problem here that will show up. And if someone gets the next port number, maybe you will always get a failure when you're trace routing the second router away from you or something like that.
Yeah, the next port number is going to be annoying for whoever gets it, and the one after that, and yeah. So yes, IANA is aware of the problem, and I think is going to try and not use those ports. I think they're making sort of a note. Part of the problem is the person who somebody would need to convince is Joe Touch, because he's the port registry person, and Joe Touch seems to not be convinced that this is a problem. So I think what it is for now, IANA is going to try and assign from other sets of numbers, but Joe seems opposed to marking all of these ports as known in use by other applications. From what I understand, he said Unix implementations should all just replace their trace route. I think that's what he said. I'm not going to comment on that.
Yeah, and that's of course also another thing, whether there is some way of approaching them, but I'm not sure how well that would work. Yeah, but at least this problem will show up in the future too, probably.
All right, thanks for that, guys. Appreciate that. So first up, we've got IPPM hybrid two-step. Is that on the agenda?
Yeah, it's actually both of those drafts together in one presentation.
Are they? All right. So I thought we had three stacked up here. And this would be you, bro.
And while you're doing that, I think Lenny wanted me to just give a brief update about the Wi-Fi multicast draft. So, yeah. So I'm going to do that outside this real quick. So is it working?
Yeah, just take people's eyes out with it.
Oh, it's the laser pointer. Yeah, and I don't need this. But so with that particular draft, I just had a meeting with Eric. I don't know his last name, from Cisco, AD guy. And how you say it? Venk.
Or Vinky.
Vinky. Okay, either way. And so that particular draft is under his review. It's been sent back to us, the authors, Warren and I and Dorothy and Charlie and others, to address a few other comments. And some of those comments are pretty extensive, unfortunately, even though we just are kind of done with the draft. So I've been kind of busy updating the draft and will continue to do so. So just make a note for the notes that the Wi-Fi 802.11 multicast considerations draft is still it's in AD review. Let me get to these drafts. So these drafts are just an advertisement. Just wanted to make sure that Mboned were aware of this work since we do OAM types multicast work here. Greg Mirsky presented this in IPPM a couple of days ago. IPPM is IP Performance IP Performance Measurement. And it's only been focusing on unicast up until now. There's solutions such as IOAM that many of you may be familiar with, in-band OAM type mechanisms where you do OAM in the packet instead of out of band. And so with these solutions, there haven't been a consideration for multicast. So multicast traffic monitoring is important. I presented this in PIM IETF or two ago, and there was some interest from the operators. So the purpose of me presenting these drafts to you is just to see if there's any interest. If there is, please join us in this draft. It's being worked on in IPPM. And so, let's see. There are current problems with the existing telemetry techniques. They have issues. There's not a branch identifier, which I'll talk about in just a moment. And there is unnecessary replication. Right now with IOAM techniques for unicast, there is traffic capture towards the head end of the flow, and it's propagated all the way down to the end. And for unicast, that's a good thing, but for multicast, it can lead to unnecessary collection of data. And so we're trying to prevent that. And so there's some things that we've done to help prevent that. So next slide. So there is something that's called postcard-based trees, and it's a proposal to, on each branch, you're sending up the data to a collector along the path. And so that until now also hasn't been something that's supported multicast until recently. And so with this draft, what we've done is we've added a branch identifier to the instruction header to provide a indication that this is a unique branch along the flow. So you're able to send up that data to a collector along the branch, and these different branches have different identifiers. Next slide. So Greg Mirsky has this hybrid two-step solution. It's also something that is being modified to be able to support multicast. And so the branch node forwards that hybrid two-step over the first branch and then originates follow-up packets downstream. And so that's something that he's leading. I'm not on that draft. Next slide. So there's also a way to do it instead of per node. You can do it per segment in postcard-based telemetry. And so a postcard is sent at each section's end node, and that postcard contains the data for the entire section. And yes, next slide. So this is the last slide. So again, your participation is welcome, encouraged, particularly operators. I think someone from Deutsche Telekom mentioned last time that they'd be interested in this kind of work because it's very attractive, particularly for multicast. And we are will pursue working group adoption in IPPM. Any comments or interest from anybody?
No. Shepard's chair.
Yes.
Which group are these active in?
IPPM.
IPPM.
IP Performance Measurement. So just know that they're now working on multicast.
That's kind of exciting.
It is exciting.
Wow. Who started that work?
A colleague of mine, How You, and he was not familiar with multicast at all. So he and I started working together, and Greg Mirsky as well.
Okay. Fantastic.
So it's good. And Greg is familiar with multicast.
Yeah,
so.
absolutely. Thanks.
Yeah.
Hi, Jay Collin. Is there an implementation? Is it something we can try out?
I don't know if you can try it out. There is implementation, but it's in a country that you may not be able to try it out from. So,
okay, this seems potentially interesting. I don't know yet whether I can use it, but I might take a look.
Please do.
Yeah.
And join us if you have interest on the draft. I mean, authorship is
Yeah,
open.
so there's interest and there's, you know.
No, I understand. I fully understand. Thank you.
Copious amounts of free time. Thanks, Mike. You're doing that next also?
That's it.
All right. Next. Oh, that was the,
That was both.
both of them. Got it. All right. Lisp demo. Lisp. How do you spell that?
Don't stutter.
It's a whole different affliction.
I'm low in charge, so I have to bring up a lot of hardware. And I need audio, so.
This is a puppet show?
Yeah, it's a puppet show.
All
It's a
right.
demo. It's showing you running code. versus crashing code. So fast. Okay.
Well, we find running. I mean, crashing's
Crashing's more fun.
part of running too.
Okay, can I do that?
What do you need?
Your HDMI.
Steel display?
Yeah.
This is a video. Right?
So I can take this.
Well, no guarantee it's all going to work again, but do what you're going to do. Dino's in the room.
And it's, of course, the stupid Cisco thing. It's not
Now
working.
you've done it. Stupid Cisco. It's a power brick.
I know.
What do you mean?
You would think it would.
You know the part of that that's Cisco? That paint right there.
That's about it. I
You
think
got power, man. Look, you're on display.
No, it's not charging it. I only have 16%. So can you figure a way, or let me use yours?
Yeah, use this. I can.
I appreciate it. Oh, so it's gonna run out of money.
It's got a lot of power. But you're going to run out of money. I was broke after that presentation. Sorry, that's my power brick. What?
Shoot.
And so you'll get a star because you weren't paying attention to it.
Yeah.
It is weird.
But I agree. I don't know why this is doing it. Okay.
Yeah.
Okay, so,
I thought it was all trace
let me show that this way.
If you trace route into the first thing.
Okay.
So hi, I'm Dino. I actually have two presentations. I gave this in the Lisp working group in Montreal. It's Lisp mobile node, which is running Lisp on a mobile platform like Android or iOS system. And this was a unicast demo. And what I did here in Singapore at the Lisp working group is give a multicast demo. So I asked if I could give the multicast demo here and thought that this showing unicast first may give some good background.
That was close. You almost got kicked out.
Okay.
So what we're demoing is Lisp mobile node running on an iPhone. There's an iOS implementation. We have RTRs, which are, I don't know how many, I think some people here know this, but it's re-encapsulating tunnel routers are deployed in Google Cloud and AWS. And the Lisp mobile node to Lisp correspondent node can talk to each other behind NATs, as well as Lisp mobile node to non-Lisp correspondent nodes behind NATs. So two Lisp entities are on the overlay and can talk to each other. That's what the third bullet is. The fourth bullet is a Lisp mobile node can talk to a non-Lisp anywhere in the internet. And the inner working is done by using something called LispNet. It's one of the RFCs. So some magic sauce is Lisp is not running, a Lisp mobile node is not running a control plane. That's the whole point of this effort, was to build a really small scale, small footprint implementation of it. So basically it's configured to have a default route that points to a set of decapsulating routers, either proxy ETRs or RTRs. And that's something that's configured in the implementation. User would have to configure it. And the RTRs are configured to glean XTR mappings. So in Lisp, we have a NAT traversal proposal, but that requires control plane messaging, which we are trying not to do here. So basically, the NAT traversal proposal uses control plane mechanisms, but this gleaning is using a data plane mechanism. So all the logic occurs at the data plane. And this is in an effort to implement a lightweight XDR. And there's a use case that we're looking at to do traffic reporting using H3 grids that Nexagon's doing to be able to put Lisp and dash cams in existing automobiles rather than integrated by the manufacturer. So here's the demo topology. We have an iPhone over there on the left that has an EID of 13 and a Docker container that's running on my laptop that's EID 14. And then we have two non-Lisp nodes that are labeled in red. One's the Google's DNS server, and then just www.lispers.net is where my website is hosted, but it's just a non-Lisp site. Okay, where you see green, those are the guys that are part of the overlay, and where you see red, that's the underlying routing stuff. We have a RTR that's sitting, the G-RTR1 is sitting in GCP, and there's three sitting in AWS. The implementation on the iPhone is OOR. That's a public domain implementation that runs on both Android and iOS. And the RTRs are my implementation from Lispers. Okay, so I hope the last time I tried this, the audio came through that box and nobody could hear it. And if that's what happens now, I'll have to annotate myself. So let's give this a shot.
I can do the voiceover.
Okay. Oh, wow. The volume should be all the way up. Yeah, right. All right, so let me.
Is it coming out of that monitor then?
Oh, it's coming out of TV. Okay, so let me just
crawl into that hood, and it will be a puppet show. Dina's behind the black curtain. This is awesome. All these like middle school AV guys are just having a ball.
But maybe you can explain up front. Are we going to listen what's being said, or what's?
No, I'll go ahead and just do it myself. But unless these guys think they can fix it in 2 seconds.
Okay. Come on, let me do the voiceover. Hi, I'm Dino. This is my Lisp multicast demo.
You'll ruin it.
Oh, come on, I give it a little character.
Yes, you sure will. Okay, here we go, and let's try it again. Okay, so the idea here is that the Lisp mobile node is going to be sourcing packets, and it's going to move between Wi-Fi and LTE while the pings stay up.
Yes. Use the mic, man.
Oh, sorry. Okay.
Say it again.
So the Lisp mobile node is switching between Wi-Fi and LTE. And it's going to send packets. So right now, this is the 14 container node that's sending packets to 13, which is this guy. And I have Lisp enabled, sorry for the shaky. That's the EID, and it's configured with those PTRs. Here, I'm going to originate a ping now. See, I'm on Wi-Fi. And now what's going to happen is I'm going to ping www.lispers.net. And the pings start going. Sorry for the shaky. The multicast filming was better. And so this guy is pinging this guy. And it turns out that this guy is translating the source address of 13 because it's an EID, which is not in the underlying routing system, to the IP address of the link that's going into from Google. Now what I'm doing is I switched to LTE. In other words, turned Wi-Fi off, and the connection's still. The pings are still happening. If you look in the RTR, you see 13 and 14 are talking to each other. The dark green packet counts means packets have been forwarded within the last second. These have been forwarded in the last minute. And so the connections happen. The phone's going through 166. That's my AT&T link. And 96 is happening in the container on my laptop, sitting at my house using Comcast. And let's see, am I going back? Yeah, I'm going back to Wi-Fi now. And then you'll see that the RLOC's going to change to the same 96. Of course, it's using a different port number because we're natting through my house. And that's what the demo is supposed to show. Cool?
Absolutely.
No, thank you.
Didn't you say something about multicast? I overheard that.
It's the next presentation.
Oh, that's the next presentation.
There's two demos,
Okay.
and I wanted to give you some
Ah,
context.
okay. Cool.
Okay.
Pitchforks were getting out.
So it seems that the new list parts, I don't know, are kind of to make the stuff on the phone smaller, a lot more lightweight, and support NAT and so on, right? Is that true? So basically, the phone is just the demo thing. The actual device it would be is a smaller, lightweight IoT device like a dash cam or whatever is small enough just to have the radio, but not much else. Right?
I mean, it could be used on the mobile phone just like this as well. But yeah, you can run a full control plane.
Well, because I thought I'd seen, from you in Cisco, Lisp on mobile phones many years back.
Yeah.
Kind of the oldest. So there was.
Yeah, we first did it on Android, and it wasn't a completely full implementation. It adhered to the Lisp mobile node spec. So it didn't do the full XTR support, but this is doing even less than that now because we want it to be lighter weight.
No, that's fine. Cool.
Okay. So next thing is then I tried basically a load split ping test, which was really easy from the container to www.lispers.net. And the idea here is that let's use all the RTRs and load split traffic. And what this is showing that is on the container, there's the 0/0 that goes through all four RTRs that are one in Google, 3 in AWS, and they're load splitting traffic across it. So that was another thing we could do. Does that come? Oh, okay, that was interesting. And so what I wanted to do, I go, okay, let me drive home. I was at the coffee shop, and I said, okay, I'm going to go ahead and open Apple Music and download some music, and let's see if I could hear any audible differences coming down. So what happens was when I was sitting at Pete's, I was connected to Pete's Wi-Fi, and, we always see Xfinity Wi-Fi all over the place. And so what happened was as I was at Pete's and moving around, I was switching between those. And then I decided to get in the car and start driving away from those, out of signal from those guys. And of course, AT&T LTE was up. It said 5GE, laugh out loud on the corner, but it didn't matter. And then when I got closer to my house, which was more rural, then it actually switched over to 4G. So the audio kept going. I was downloading the music while all this stuff was going on. And I didn't hear any audio loss. Go ahead.
All right, Kyle Rose. I'm not super convinced by that because don't these players just, like buffer stuff to make sure that there's enough available in case there's a temporary connectivity loss? I mean, I'm not saying it doesn't work.
Yeah.
I'm just saying this may not be a convincing demonstration of that.
Yeah. I was driving for a good half hour. I don't know how much buffering was between the points, but that's a really good point. Okay, so some caveats about what's going on here in the design is the Lisp mobile nodes must send before it can receive. Since the RTR is gleaning RLOC information from it, return packets cannot go back unless it's sent. So if we have the silent source problem, we have this in so many designs, right? This is a problem too. So if two mobile nodes wanted to talk to each other, they would have to send somewhere else. This is really not a problem because as soon as I bring Lisp up on the phone, it's trying to talk. The iPhone with all the applications are running are trying to talk to so many non-Lisp nodes that they are able to send. But there is some latency associated with it because you have to discover the source, you have to punt it out of the data plane, and then put it into your map cache before a return packet comes. And then there's also the asymmetry problem where if mobile node 1 sends the RTR1 and the return traffic comes through RTR2, then the gleaned information is not in RTR2. So that asymmetry causes a problem. They must, to do that, they have to use the same 5-tuple hash on both sides and be configured with the same RTRs on both sides, and then there's symmetric forwarding. Go ahead, Steve.
Yeah, just a quick question. So do you statically configure a specific RTR on your mobile node?
Yes.
Okay.
Absolutely.
Yeah.
We configure the mobile node with an instance ID so it could run in a VPN and an EID, and we configure it with a list of RTRs and do not configure a map server, so it's not using the mapping system whatsoever.
Right, it just always uses the RTR and that knows whatever.
Yeah, it's just basically everything it originates just goes. And you'll find out for the multicast that there's some interesting control packets that just get encapsulated there too, and you can guess what that could be.
I know it's also kind of challenging to implement multicast on an RTR in general. I know it can be done, but there are some.
Yeah.
issues,
Yeah. I mean, there's replication engineering issues. Yeah, we very well aware of that. I mean, the same issues that everybody's dealing with AMT relays too, right? It's the same sort of thing. Okay, so to-do list, we want to enable RLOC probing for reachability. So we want to be able to figure out if from the OOR point of view on the phone, if the RTRs are reachable versus not. And when they're not reachable, they use the other ones that they have configured. And we want to be able to use Lisp crypto, which is data plane encryption. So the RLOC probing has to contain key exchange, and we have an RFC for that is used. But we want to change the implementation to support that, and then maybe support multiple EID and instance ID support. So if you have professional, it's a work phone or is it a personal phone, and you want to run separately, you could be able to do that. So multi-tenancy support is what that is. And then, of course, I said in Montreal, we got to do multicast to complete the picture and show that at this IETF. And so that's what I'm about to show you now. Yeah, go ahead.
Sorry, Kyle Rose again. Is this unicast? The connection to the RTR, there's only one of them on the phone, right?
There could be as many as you configure.
No, but I mean, in this demo, there would have been one, even if you were going to multiple destinations, multiple Lisp EID destinations.
We did it with one, but it does work with 4.
No, the only reason why I'm asking is you don't run into. This isn't limited to working on certain kinds of NATs, right? You don't run into the problems that like the stun or turn people did. It's just once you make an outbound connection, that port assignment on the NAT is stable and you use it for everything on the.
Correct.
Okay,
Absolutely.
So it's not coming from a different source address. You're not going to get packets from a different source address trying to send packets back to the phone on that port. It would always be.
Well, the only way the RTR gets a packet, the outer header has the translated source and port information in it, and whatever translated, if it was 2 NATs that did it, it's going to go back to the first NAT. So this stuff does work through double NATs or triple NATs or whatever.
Oh, I guess maybe the way to
this
ask.
Demo actually goes through 4 NATs because when it went from my house to GCP, there's NATs there, so that was a double NAT and sometimes triple NAT. So
sorry, yeah, I guess the best way to ask the question that I was asking was it's a connection. It's essentially a tunnel to the RTR.
Absolutely.
Okay.
Yeah.
Perfect.
It's a dynamic encapsulating tunnel in UDP. Yep. Okay, so multicast. We can go through this quick. So what are we demoing here? Again, Lisp mobile node on the iPhone. The RTR is deployed in GCP, and we're only talking Lisp to Lisp on here because it was difficult to do non-Lisp, but I have a surprise at the end that you guys might enjoy. So all multicast sources and receivers are on the Lisp overlay is basically what the demo is. Okay, this is all basically the same thing. It's the same configuration, we want to do lightweight stuff. And again, everything that's originated by the phone goes to the RTR. So Lisp mobile node is a multicast receiver. Well, when you bring up the application on the phone, it will send an IGMP report. Of course, the IGMP report is just encapsulated like any other packet. So the RTR can track group memberships from all the IGMP reports it received. And then the RTRs just replicate the packets to all the group members, no matter where they could be. When the Lisp mobile node is a multicast source, the Lisp mobile node sends multicast packet, just like any other packet, to the RTRs. So it doesn't matter if it's unicast or multicast, it just sends it to the RTRs. And the RTR has the group member list, and so it can replicate there. And I'll talk about in a minute how it does it with multiple RTRs and members joining to different ones. So basically, the demo is showing that the List mobile node can maintain multicache session continuity by switching between Wi-Fi and LTE, either as a receiver, a multicast receiver, or as a multicast source. Okay, so the demo setup is pretty much the same as last time. We had 13 running OOR, and we have 25 and 14 as 2 containers running. And we're going to do 2 types of sub-demos. The first thing we're going to do is we're going to show that there's a multicast video source sending to 224.111 from the container, and the receiver is the phone. Okay, and then the second demo we're going to show is that 13 is a multicast source sending to 224, and it's being replicated to the 2 containers. Now, let's try this again. Is it move? Yeah. So I'm basically just repeating what I just said now. Here are the 2 containers, 2 separate windows. And the first thing we're going to do is the ping. So we're about to set up the phone to send the ping. And you'll see things scroll here. So we bring up the phone. This is a shell, a brute force shell window. And we're going to ping 224.222, which is for the ping demo. You can almost hear it. Okay, I'm about to tap that. Oh, maybe I'm going to tell you about who's receiving first. Yeah, that's what I'm going to show you. So the 2 things are joined to the group 224.222. The way they do that is they register to the mapping system, and this replication list entry is added. So these are the RLOCs for EID 25 and 14. And now the ping is going, and you see it appearing there. So the replication is happening, and if we refresh the RTR, we'll see dark green there, meaning packets are being moved and replicated to the 2 receivers. We're sitting on Wi-Fi for the phone. I'm showing you packets are moving. Now I think I'm about to switch to. Sorry about my hands. And there's an interesting filming problem here. I dropped the camera. It's sitting on an easel, and I smash it. So let's see if you actually noticed it. I was pretty quick at picking it up. So now it's LTE, and you see the pings go. And then I'm going to show you how the gleaning changed from the 73 Comcast address. There's 13, but we're not sending any packets of 13, even though that was updated. So now it's coming from 166, which is the AT&T address. It's NATed address. Okay, still on LTE. I'm going to switch over now to the video demo. I'm starting, there it is. VLC, I'm starting VLC as a source here on 25. And then I'm going to join VLC as a receiver on the phone. That's what's happening right now. So the source is starting up. It's going to be a waterfall, so you'll hear some static. That's the actual falls coming down in the video. There's VLC coming up. And when I tap on 224.111, that's when the IGMP report is going to be sent to the RTR. And once I do that, we'll show the RTR to see that 224.111 was joined. I don't know if you can hear. There's the falls. You can see the falls moving and stopping. I'll tell you why that is the case. There's 224.111 and 13 is joined to it with its RLOC. Note it's a 166 RLOC, which means it's LTE. Still, you hear a little bit of audio, but now note this is actually all the receivers and sources are at my house going all the way deep into GCP and back, and that's why you see these delays because the RTR, everything's hairpinning, right, because it's a long path. So the RTR is not placed in the best spot where all the sources and receivers are, and that's always been a problem we've had with, rendezvous points and AMT relays and stuff like that. So now I switch back to Wi-Fi. You see the 73 address. You notice the 224.111, both the unicast address of the EID and the group that it's joined is 13.13.13. And that's it. So we're able to move across interfaces, keep the sessions going, and replicate both in the receiver and sender case. So some observations. Gleaning latency does not exist as it does for unicast. So that means that the reason it doesn't exist is because it's a unidirectional flow going from the phone to the receivers. The gleaning information for unicast would only be useful if unicast packets were coming back. So since the source is just sending to the RTR, gleaning as a source is not important. But of course, it is important as a receiver. However, you can't get the multicast data until you send the IGMP report. So when you send the IGMP report, the group membership is added and the gleaning happens at the same time. This is where multicast has an advantage over unicast. Now the problem is if members are spread across RTRs, the Lisp mobile node needs to send to all RTRs. And so we have a draft called Lisp replication engineering that shows how to put layers of replication engines in. Since this is an overlay replicating multicast packets in unicast packets, we have to, in doing head-end replication at various spots, we have to do this at various locations. The problem is OR defaults to one RTR because it's just any packet. It does a 5-tuple hash and picks one of many RTRs. But if the receivers are joined to other RTRs, then you have a problem, like this case right here. If the mobile phone was sending here, this guy would only be replicating to what's joined. But of course, what you could do is you could have downstream RTRs set up that these receivers are configured that join to. And then since these things are registered to the mapping system, when a source just sends a packet to the upstream RTR, the mapping system says that there's a replication here. And so rather than having 4 replications at the source or 4 replications here, you have 1, 2, and 4 where they need to be. And it's relatively efficient, ignoring the underlay, because the underlay always does interesting things. Do you want to ask a question? Go back.
Jake Holland. It was actually about the notion of switching to an underlay instead. Like if you enter an underlay that does provide support, do you have any vision for like how it would swap between them and sort of leave the overlay alone except when necessary?
Yeah, funny you said that because you just created a segue to my next slide, which is the surprise I have for you.
Great, thank you.
But thanks for the question. Yeah, that's a plant. I'll pay you later, Jake. Yeah, go ahead.
Stigmanas. So if the RTR had like native multicast, it was like in a pin domain, whatever, then it would work fine sending and receiving to from native multicasts, right?
The answer is yes, and that's also a segue into the next slide.
Okay.
So the RTR typically decaps and re-encapsulates. If it just decaps and needs to place it on an interface, that would go into an ETR function. But it's just a matter of that the ETR knows not to do another map cache lookup to try to re-encapsulate it because it's at the end of its thing, right? Good question, though. Tor, how am I doing on time?
How you doing with your Tor? Get up here.
So
okay on time.
Okay. What is this, by the way? ASM, SSM?
Neither. I don't care. So what happens is...
What's the joins, the IGMP joins?
It's an IGMP v2 join on the group.
Okay.
And what I decide to store in the mapping system is a 0/0, 225.111. So that is a source-specific join, kind of, but it's really star G because it means everything. And the reason I'm doing that is because I don't want to inundate the mapping system with S, Gs. So it's really a star, G design without an RP. Purposely done that way.
Okay, so that is ASM. So every source can send. Did you?
There's no joining and pruning off SG trees, so that's why you can't say it's ASM because
I can say it's ASM because we never mind.
You can't say it ASM because it's not PIM.
No, ASM is the service model. It's not the protocol.
Okay, whatever.
It's just you're joining a group and you get the traffic from all the source. That's all it is. It has nothing to do with PIM.
Yeah, right.
It's
okay,
fine. Okay, cool.
And if you want source specific state in there, you can put it in. And since the map cache lookup does longest match lookups, it does a longest match lookup on the destination first, and then does a longest match lookup on the source. So you could have more specifics.
I don't
And
care
guess
about,
what? That's really important sometimes, because if the source is going to move, it may move to a different spot. And there's no RPF going on here, but sometimes you want more specific because you want to be able to detect that the source has moved away from 0/0. That's an advanced
I think
topic. We just talked about that over beers.
No, I think the interesting stuff about SSM would primarily be as an access control mechanism, right? If you don't want to allow everybody to send, what type of access control, let's say, do you think you want to have?
You can access.
This may go beyond the demo, so I don't want to.
Yeah,
Yeah.
Well, I mean, really quick answer. You can access control by limiting whoever sends map requests to the mapping system. You can say who gets answers versus not. So now in this lightweight control mechanism, a map request is never sent by the phone because it always matches 0/0. So there's never a map cache miss. So you would have to filter at the data plane. But most of the policy-based and filtering stuff in Lisp happens at the control plane because we don't want to do data plane ACLs because it's a total mess in the network, as everybody in this room knows.
That's basically control plane is access to the surface, not access to the content. Anything beyond that's application layer.
Absolutely correct. Yeah. Okay, so we just started this a couple weeks ago. This is kind of a work in progress, but Lenny wanted to try some stuff where he said, can we source some packets from a mobile phone in Lisp and then bring it into the AMT cloud? And actually just this morning we got it working. Well, we got working at the Lisp working group, I said, we got it working because packets came in here. But as of this morning, the packets came to the gateways. And I said I really wanted it to work because I wanted to show you guys in Mboned what's going on here. So the idea is we were just using ping as a source from the phone. And of course, we had 2 Lisp receivers. And then we have this ETR here joining the group. And so basically the GRTR1 was replicating to 3 places. Now, what's really interesting, we did this at the Olympics as well. What's really interesting here is that packet is being sourced by 13. To 224.333. If you dump that into that native Mboned there, it's not going to RPF, right? So this is an inner working function where some receivers are non-Lisp and some are Lisp. So what happens is the packet, after it gets decapsulated here, since we have this NAT configured on there, it actually translates the source address to the IP address of this interface here. So the AMT relay believes all the packets are coming from this prefix coming there, and that's why RPF works all the way through the cloud. So the packet actually makes it through that native multicast cloud, and the AMT relay then picks it up and replicates it to the gateways that have been joined to 224.333. So the OOR is running on the phone, listverse.net on the RTR and ETR, and a Juniper is the AMT relay. So did I answer Stig and Jake's question?
Sure. My new question is, where do you get the ETR source IP when you're trying to join something and get the RPF in the native cloud?
Well, the ETR.
You're just going to know, I guess?
So are you saying how does the joining happen down there?
Yeah.
Yeah, so that was a question I had for Lenny. He goes, just do it static, right? Right now, this guy's static joining 224.333 to drag it down, right?
Okay.
But the thing is if you co-located Lisp and AMT relay, it would hear the groups that are being joined through AMT, and then it can register it to the mapping system and pull it down. So the only reason it's like this is because it's disjoint, and we got this push-pull conflict as you're stating, right?
Okay.
Right.
Interesting. That might. Okay. Interesting. Yeah, thank you.
Yeah, no worries. Stig, I answered your question? No? Yeah. Okay. So that's it. Any other questions? Thanks.
That's fantastic. Yeah. Thank you very much.
Thank you.
Running code. And the next is running code too.
Huh?
Back-to-back running code
Good.
demos here at Mboned.
Yeah, real stuff. I just have to get in the right direction. There we go.
Get it back.
Yep, got it all. Thanks.
Well, you say I'm left with a blank screen.
You're on your own. Maybe I see
Is it going to recognize it?
What's this? So that they
Make
should
sure
be under a demo, so
it's pushed. You might not be pushing it all the way through.
That's not a big
You certainly should use anything. Yeah. Maybe pick the closest one, just like the YouTube.
Yeah.
You're next. And we can't get slides up.
Should I bring my computer?
Maybe.
I knew I shouldn't have let you unplug this before.
I know, I was thinking the same thing. They always let him go first before Tina tears us apart.
Oh,
Yeah, but you need some bone lattice, right?
Oh, yeah.
I don't know how to turn this thing on. It's Chrome or something. How do I get? Oh, it's a Chrome book. So there's probably something like this. Full screen slides.
He was, if it follows.
I can plug my computer in if I need
Yeah,
to.
you grab it.
But you need a bone lattice.
Four full screen slides
Well,
for sure.
all that does is, I mean, it hasn't changed the access to the display, right? It's just changing my view.
No.
Oh, I did.
I plug this thing, I guess. I don't know what.
Oh, you,
That's weird, because you plug it right into your laptop and it
yeah. Do you,
recognized it.
you want a dongle, Jake?
This Chromebook is just,
I think I have
violated something.
Jake, I can help you with this.
I think I got.
Just yank it.
Oh, you have it on Oval.
See if
Oh, yeah.
wiggling it works first.
It's been doing that.
So you.
I should have agenda bashed up my fault.
Yeah, I had you set up this first and change it around. Somebody, those people are expecting, they can't come right away. Exit mirror mode. Oh, I don't want to exit mirror mode. I want to enter mirror mode. Exiting mirror mode. How do I get back into it? You on? You ready to go?
I was just thinking if I'm willing to just discover and use whatever RTRs closest to me.
But if it's well known and hard coded, that can't, that might not be good.
Yeah, give it a dog.
Yeah,
You buy it.
Because then you get
Just stop. Sorry. Amateurs. Well, it used to be our own shit. It's not our own shit anymore.
Okay.
Close and open the lid. Someone sent me that message?
Oh, close and open the lid. Yeah, try it again. There you go. It's better if I can.
Hysterical. I like this message from beyond.
Yeah, it's kind of nice the way just God kind of reaches in and tells you the answer sometimes, you know? Having somebody watching. Do you want this?
Boom! Yeah, would you?
Thank you, Miyoko. Okay. Did I just? All right. Am I buzzing? It sounds like I'm buzzing. Okay.
Buzzed, but you're not buzzing.
All right. I'm Jake Holland. I'm going to talk about multicast to the browser. This is a project I'm working on. It's composed so far of these three drafts and a WSCG proposal, which is posted here. Where's my? Okay, so the goal here is to receive multicast in Java, JavaScript. This is a, and the goal behind that goal is to port receivers to WebAssembly and distribute them over web pages. I specifically want to include here proprietary players and downloaders because, I have one, and there are something like 6 at least others out there, and plus BBC's thing, and I would like all of them to work so we can just sort of fight those protocols out in production and see what actually performs the best. And the goal is, my main two use cases are playing video and downloading files. There may be other things, but those are the things I actually want. And the second goal is to do so safely, so that so that it can be accepted into the browser check-in sort of ecosystem. So, you know, when you talk to the browser, to people who work on browsers, they're highly aware that all web pages are malicious and that all JavaScript inside even non-malicious web pages are also malicious. So the goal here is, and likewise that the network itself is typically malicious. So I am trying to address the sort of security model that they're used to working with in browsers, as opposed to the kind of walled garden places where multicast has so far been successful. The two main things that I'm trying to accomplish at this point is to resist on-path injection and or packet modification, and to prevent malicious pages from doing anything to the networks that are trying to receive the multicast. So these are the specs, and the things that they do is the WICG spec that I mentioned is tries to define a multicast receiver API in which the page can do a join and start receiving traffic. The IETF specs that I have, one is called dorms. This is discovery. I'll go over each of them in a little more detail, but the broad outline is that there's just metadata that is available to the nodes that need to have the metadata. So it is the kind of substrate to provide this metadata, which I'll go over briefly. Ambi, it uses this metadata to provide the information necessary to authenticate per packet the data that's being received by the browser, or even by a sort of multicast firewall, you could think of it. So you can put one in the network to prevent injection from outside it, for example, an ingest point with your AMT gateway. And then CBAC is another different usage, extending the metadata such that you can detect whether you're going to be oversubscribed, so that you can maintain your safety thresholds about how much traffic you're willing to be subscribed to, and avoid joining the flow if you would have exceeded that threshold. There have been some suggestions about maybe providing a way to trim it. I'm totally open to that. This is still very early work, but these are the general outlines of what this is trying to accomplish. The way that it's implemented, or the way that it's it would move forward, is that there's this JavaScript over on the left, and it's just going to create a multicast receiver object and pass it a callback for receiving data. So you just issue a join and you start receiving authenticated payloads if you are indeed successful. This can do the tunneling with the Dryad that we've lately been that has, I guess, just gone to last call, I think. And the idea is that inside the browser, you can provide all the guardrails. So all these pieces that are trying to provide safety to the network, even if the JavaScript is malicious, it's limited in what it can accomplish, because the browser is going to notice that, oh, you tried to join something that's too big that would blow out the network, or that would blow out the thing. And it's also going to be able to monitor the loss. Ambi provides manifests, and the manifests give you, so I'll get into that in a moment. So it's essentially just making the decision, is this safe to join? And then after issuing a join and starting to receive traffic, noticing if something is out of whack, and providing that feedback to the JavaScript, and providing a backstop of cutting off the JavaScript if it turns out that this is even worse than we thought for whatever reason. In addition to the browser providing safety checks, the network also can access the same metadata, and you can operate a sort of in-path network firewalls that can do the same kinds of operations using the same metadata, which I'll go over again in a moment. Now, and the authentication and loss detection is you may or may not to choose to run it in your browser. This is, I've written it as inline router, but I think of it in practice probably more at an ingest point or at a choke point of some sort for your network. So dorms. Dorms is discovery of RESTconf metadata for SSM. I've defined a very small, very simple Yang model for, and the intent is to run it in a RESTconf server and to use this to publish indexable metadata per SG, so that you can provide so as a sender, as a source of traffic, I can put up my dorm server, I can seed it with the metadata about my streams, and I can and then anybody who's trying to join traffic that I've provided would have access to fetch it from my dorm servers using these nicely well-defined web APIs, essentially, that specify the format and the meaning of the various fields within the HTTPS requests that are going back and forth. RESTconf provides so all you need to start this whole thing is the host name of the dorm server, and then you get to do you get the hooks to bootstrap up to finding the appropriate metadata when you know the SG already. And then it also provides particularly for the browser, when the browser is going to require access to the metadata, then from the server side, you can check the origin header and refuse to allow browser, like malicious ads that came from the wrong kind of page to join a stream from an inappropriate source, just by refusing to provide the metadata to the browser, right? So there's a viable threat model that is prevented from executing. So what it looks like is, as defined, is just you're going to issue a get for the metadata. It has the SG provided, and then you get, the dorm's substrate for passing the metadata is very stupid and has almost no useful information. It just has the structure of where the SG is. But when you put metadata into it, it's done as an augment of the dorm's metadata, and it ends up looking like this instead. So that you make the request, and you get something that has actual useful information in it. This useful information being, here's what you do in order to go perform the authentication. All right, same thing for CBAC. It's just a little bit of extra stuff. Okay, so on top of the substrate, we put AMBI, which is asymmetric manifest-based integrity. The idea here is that you are going to provide an authenticated stream of out-of-band manifests. The manifests contain hashes of all the packets, so that when you are receiving your multicast packets, now you have an authentication stream, which is provided, authenticated through an out-of-band mechanism, and you just cross-check your manifests with your hashes, so that you can decide the things that you've received are the things that the sender actually sent you, and the things you did not receive were the sender thinks he sent them to you, so they must have been lost. Okay. The phase one looks roughly like this. You've got the receivers down the bottom, right? And they, if you get a packet without a hash, it was spoofed or corrupt. Hash without a packet is lost. You've got the multicast data coming down and being forwarded through whatever, by hook or crook, however you can get it. And you've got the authentication data coming down as a unicast stream containing these hashes. And the authentication data, depending which hash scheme you use, is going to be like 1 to 3% of the data you use. This, by the way, assumes a full-size packet approximately. If you're going to use 20-byte packets, then you're going to have approximately 100% overhead instead. But that's, well, no, The hash is a crypto hash, so you're going to choose the crypto algorithm. You can it's selectable. The one I'm running in the demo is Shake128 16-byte hash. You can, if this is proven to be insufficient, then of course you can choose a 32-byte hash with SHA-256 or whatever it will end up on. Yeah. So in phase 2, we've talked about this a little bit before, but the goal is to turn it into something that's going to have signatures inside the multicast data stream, so that you can authenticate by listening to the multicast stream, and then you will not have 1 to 3% of unicast data overhead, but you'll have a similar. It might be a little higher. It might be like 5% overhead, but it'll be inside the multicast stream, so you don't have to. You no longer have a new unicast ceiling on what you can accomplish at only 50 or 30 to 1, but rather a multicast thing with a little bit of extra. Yes, Kyle.
Kyle Rose. Yeah, just to the point about the hash length, I think we expect to have a fight with the security directorate over how long the hashes need to be relative to how timely the data is. Basically, if the data is only valid for 2 minutes, then do you really need a 32-byte hash? Not clear.
Yeah,
but that's
even a
this is a
16-byte
longer term
hash.
discussion. Sorry.
Yeah, even a 16-byte hash is like questionable. Do you really need that? But you know what? It's fine. I don't care.
But
I'm happy
it's
with
something
either
that's
one.
on our radar, right? Because overhead matters in this.
Overhead matters, but I'm actually happy with either at this stage. Okay. CBAC is the circuit breaker assisted.
Just comment to that too. You just throwing a number out, 5%. The unicast case is 5% per receiver. Once you're in band, it's 5% for this session, right? So it's a massive reduction.
Oh yeah. This is a massive reduction. It's just not. I mean, even the unicast case, it is a massive reduction. It's just not my end game as far as I see it. Okay, so CBAC. The idea is that the metadata provides the max bit rate for the stream, and the place at which the controller is operating, which would be in the browser certainly, and also perhaps in the network. I think this is more useful in the network than the authentication probably, as opposed to the browser. But regardless, you can operate it anywhere that can cut off the multicast stream or trim it. But the idea is that with the max bitrate information that you've got inside the metadata, you have enough information to decide whether the bitrate that you're subscribing to is safe for the context you're operating in. Right. So the 100 gig stream that's going to South Korea will not be going into the rural Indiana ISP that has the mom and pop set up with whatever they're running as their ingest. So the oversubscription threshold is something that the place where the circuit breaker is operating can decide how this is best maintained. And in the browser, I'm going to be doing something dynamic, which will sort of monitor the loss rate and grow when the loss is successful and shrink if there's too much loss happening, and provide some kind of an event-based back and forth with the JavaScript to notify them that they're about to be cut off and let them respond gracefully, and then cut them off if they don't, and to notify them about the loss that they're experiencing, and to maintain that within the browser context, regardless of what the JavaScript does. In the router case, I imagine it being a more sort of managed case that's up to the network to implement how much multicast traffic you're going to permit in your network, and what percentage are you going to put on which interfaces, and that's just sort of up to you to configure, or let your systems automatically configure. But the goal is that at any place that needs to, even when there's a broken link downstream, something that's misbehaving, an agent that's not a browser, say, can join these things also. I would like the networks to be able to provide the multicast service, and when they are providing the multicast service, they have to have some kind of sane protections against how this works. Now there is a pin population count RFC that I think is worthwhile and interesting. So that yeah, is that yours? Yeah, thanks. So this is a really helpful, if it's implemented, way to sort of decide what, from an upstream router, which are the things that are worth cutting off if you need to cut something off. Regardless of whether it's there or not, you can make a decision that keeps your network safe. And my hope is that this makes it more plausible for networks to have a way to, with these guardrails, to deploy these things. Okay. So implementation is early days, but we do have some pieces of this that are starting to come together. So the intent here is I've published a multicast receive library that's SSM oriented, and my intent is to add all this functionality into that library over time. Now I've taken this library and I've put it into the PyTaps implementation, and I've also run a prototype running inside Chromium to receive the data and pass it into a JavaScript API. It does not yet implement all the bells and whistles that I talked about here, but just to make sure that it kind of works, those pieces are together. And then this time at the hackathon, with the help of Max in the back there, we put together a PyTaps implementation of Ambi so that we can send the manifests, validate the data that's received, and check it before passing it into the application that would be using it. So this is, proof of concept. We didn't run into any trouble. It's a very simple sort of strategy, and I'll eventually be moving this into the C library and making that a part of the underlying piece. Obviously, there's put the actual dorm servers up and do some work on CBAC. I expect to iron out some of the pieces there. And add tunneling to the received library, probably. Certainly the DNS SD, find the local AMT relay idea, and perhaps optionally also the Dryad-based remote tunnel. So I was thinking about asking for adoption. I kind of would like to for the 3 IETF drafts. And I want to report that I spoke briefly with Ben Kiddup, the security AD, and also with David Black, the TSVWG chair, about the appropriateness of adopting things like CBAC, which might properly live in TSVWG as a circuit breaker behavior, or Ambi, which might properly live in the security area somewhere. In a place like Mboned. Their take was both very similar, which is that neither of these is particularly complicated, and that although they do strongly recommend an early review by the other area, by the area appropriate to it, that it would not be a problem, not be sort of out of line for work like this to happen in Mboned if the working group believes that this is worthwhile and useful. And I think that with the intent to make this a sort of interdomain multicast use case, to make that realistic, that the Mboned is the appropriate place to do this. But I leave that to the chairs in the group to consider.
Is our AD in the room? Comments? Have you spoken with the other ADs on this at all? Yeah. Okay. Right. I mean, just make sure you're aware of the conversation. That's all. Excellent. That's great info.
If you get a chance, I would also be very grateful for review and support of the WICG proposal, even though it's out of scope of IETF. This also needs, adoption and interest displayed on the appropriate lists in order to move forward in that domain. I've also been talking to a number of Chromium developers about whether it's appropriate inside Chromium. So far, I've spoken to, I believe, 8 such, and none of them have yet said that it's unreasonable. It's just hard. But the use case that I'm trying to do, there's nothing jumping out at them as a problem. Now, there's a little bit of a caveat on that because which I've called out in the proposal, in the explainer of the proposal, which is that the privacy guarantees are, in many cases, the browsers are very concerned about privacy guarantees, and some of these privacy guarantees are not going to be possible with the multicast receive functionality, because if you have an adversary that's your next top router, they're going to be able to determine what that multicast stream represents pretty much when you join it. You have to assume that this is possible for them to do, regardless of whether you're encrypting your SNI or whatever, right? So, if you need to hide that from them for whatever reason, you're going to have to VPN to somewhere that you trust and then tunnel it over that, because so I think that's not a showstopper for this. It might constrain the kinds of things that should be distributed over this kind of protocol, because but it should match up pretty well, because the intent is to do things that are so popular that many people are doing it, right? That's where you're getting a gain by doing anything with multicast receive. So that's one caveat, but it seems to be okay on that front as well. Outside that, like the reason that they took UDP out of Chromium was like because sending is a terrible idea to let JavaScript do. You're right. All web pages are malicious, right? So, but this is a receive-only API, so that's not an issue, right? Okay. So, any questions? That's all I have. Comments.
This is Stigmanas. So are there other implementations of the receive API now, or other plans? Are other people working on this, or just the receive API?
Oh, the receive API. So I'm the only one that's done anything with it yet. I mean, Max has participated with me in the hackathon project, and that was built on top of this. We've integrated it into PyTaps, so that is there's a dependency there that's established now, but that's not actually used by anybody except our own little project. So this is it's not really widely deployed, and it doesn't really do anything yet. Right. So
I was also wondering, I can see how a lot of the security and so on is useful, but would you say it's sort of optional, or if you somehow know that your browser is in a control environment or whatever, maybe you wouldn't need all of this, or I don't know.
So my assumption is that so I want it to work for generally deployed browsers. Yeah. I agree that there might be contexts where it would not be required, but my goal in doing this is to make it deployable for the general case of browsers.
So the idea would be, I mean, I could implement my own video player, whatever, take a unicast player and just use this receive API more or less. And
yeah. So the way I envision it working is, I mean, the way I intend to use it is that now that this JavaScript API is there, once it's there, then all I have to do is port my existing player to WebAssembly and plug this in as the receive path for the multicast traffic. And then the browser provides these guardrails such as it is, and then my behavior, as long as it can live within these guardrails, is fine.
Yeah, sounds great.
Thank you.
Hi, thank you very much. Craig Taylor as an individual. The point about the pervasive monitoring and the joins, etc., is, I think it's just a note for security considerations. I gave this a lot of thought previously, and you need significant orchestration within the environment to centralize the joins in some manner to use that as some kind of pervasive attack.
That would kind of break the
point. Anyone that could do that would have all the metadata they needed, even in a unicast world, either way. So just record it.
That's what I've done so far. No one has raised this as I am going to die on the hill fighting this. But I think that not enough people have read it to be confident that that will never happen. Okay. If there's nothing else, thank you very much. Please do read the drafts if you get a chance. sent. I want to thank Morton Peterson. I believe he did apparently do so and send a note to the list and in support. Any feedback, any commentary, any support, or this is a terrible idea because X would be most welcome. And
I want to go back to the list of documents you had. Did you have them?
Yeah, they were right at the beginning. Very first, the title slide.
First, okay. Because if the intent for yeah, there we go. If the agreement from the ADs is that the work could take place here, and then that's time for check the room for adoption.
Right now.
Right now, I mean, we take it to the list, but
yeah,
it was
works for me.
Yeah, you were requesting all three.
Yes, I would like to request all three. I think based on my conversations with Ben and David, I believe all three are appropriate. I think I'm making the claim myself that dorms is appropriate, and without any otherwise review. Yeah, my concern here is that I'm skeptical enough people will have read it, but if I'm proven wrong, that would be wonderful. Please proceed.
I've read them each twice. All right, you've guilted me into it, and I went down.
Excellent.
We went through the slides, and I read them again. So
excellent, thank you.
Who's read any combination of these as a start? Anyone read it? Okay, excellent. Who's read all three of them? All right, the same group. Who thinks this is stuff we should adopt in Mboned? Yeah. All right, we're in. Let the notes say we need to do this work. Fantastic. Thank you so much, Jake.
Thank you very much.
Pardon me?
Yeah, this is the second time that happens.
But true. The question was, we adopt the drafts. The other was, is this adopting work? You know, just kind of. And I think from this presentation, there's going to be more people reading these drafts now. Okay.
So can I ask? Is there anybody maybe who thinks we should adopt some of them, but not all of them for any reason?
Who thinks something's missing?
Yeah, I think that remains to be seen. I don't know anything that's missing yet, but if there is, I'll be back.
Yeah, let's find out. Excellent. All right. Anyone else not signed the blues? All right. You got a blue over there. Come on up. You got to come up now. It's just, I know more deliveries. Anything missing on this content so far? That's been great. Any more comments on that? Comments on the list. All right. Notes. Please email them to me when you've got them wrapped up and perfect. Yeah. And have a great evening in Singapore. Please try the street food. Oh, thank you.
It is really impressive.
Yes?
Oh, yeah, sure. He got completely screwed over by the hurricanes. That was really bad. So did he get a exercise?
Yeah.